This is the short notes on graphing quadratics, which is sections 4.1 and 4.2 in your book. There are two different forms for a quadratic equation. The one you're probably more familiar with is standard form, which is y equals ax squared plus bx plus c. The graph of this is a parabola. Any quadratic equation has a graph of a parabola. If it's in standard form, its vertex occurs at an x value of negative b divided by 2a. Negative b divided by 2a will give us the x value of the vertex if we're in standard form. Vertex form looks like this: y equals a times the quantity x minus h squared plus k. Again, it is a parabola. And it's called vertex form because the vertex, you can see it right in the equation. It is at the point hk. Hk will give us the vertex. So let's try one here. Let's actually start with example 2. We are given a quadratic in vertex form, y equals 2 times the quantity x plus 3 squared minus 5. And in order to graph that, we are going to think back to how we graphed this. So to graph this is an absolute value equation, but it looks very similar. We have absolute values, so it's a v instead of squared, a parabola. But we're going to do it kind of similar. So we translated this. We said the translation is left 3, down 5. And then we said the v opens up with a slope of 2, so we went up 2 over 1. And then we got our v there. All right, so we're going to do this one kind of the same, at least to start with. The translation works exactly the same. We are still left 3, down 5. So we went left 3, down 5. There's my translated point. That is the vertex. We can't just say it's up 2 over 1 because that's going to be a v. That's not going to give me a parabola. Parabola, the sides of the vertex are not straight lines. So instead, what we do is we take out the translation. If I take out the left 3 and I take out the down 5, I'm left with y equals 2x squared. That is called the parent function. The graphs of these two should be exactly the same, but this one is translated left 3, down 5. We're then going to make an xy chart for the parent function. Good numbers to pick are usually -2, -1, 0, 1, 2. We'll take a look at one in a minute where there's different values we should pick. And we're plugging those in for x into the parent function. So if I plug in -2 squared is 4 times 2 is 8. -1 squared is 1 times 2. 0 times 2. 1 squared times 2. 2 squared, 4 times 2. To draw our graph, we go left 3, down 5. There's my translated origin. This is the vertex. And from here, we're plotting these points. So from my translated point, I'm going left 2, -2, +8. From my translated point, I'm plotting the point -1, 2, 0, 0. 1, 2, and 2, 8. And we have a parabola that opens up. Let's try another one. Again, it is in vertex form. Y equals -1/3 times the quantity x minus 4 squared plus 2. Translation should be right 4 up 2. parent function, I'm taking out the translation, negative 1/3 times x squared. I took out the right 4 and the plus 2, up 2. We're going to make an xy chart, and we are making the xy chart for the parent function. Usually we plug in -2, -1, 0, 1, 2, but because I'm multiplying by 1/3, we want our x values to be multiples of 3 so that y values come out even without fractions in there. So I'm going to go -6, -3, 0, 3, 6. It's just going to be easier to plug in. You could plug in -2, -1, 0, 1, 2. Your graph's just not going to look as good. It's going to be more difficult to get the correct y values. And then I plug those in, not to the original equation, but I'm plugging them into the parent function. I'm getting points on the parent function. -6 squared is 36 times -1/3. 9 times -1/3. 0 times -1/3. 9 times -1/3. 36 times -1/3. And then from my translated point, I'm plotting these points. So I went right 4 up 2, and then from here I'm graphing -6, -12. From my translated point, I'm plotting -3, -3, 0, 0, 3, -3, 6, -12. And there's our graph. Whoops, that's pretty terrible. Hopefully yours looks better than that. That looks a little better. It's hard to draw on this. The vertex is the point. It's at a point. It's an ordered pair. Write it as an ordered pair, 4, -2. If it asks for the axis of symmetry, an axis of symmetry is a line that if I fold the graph over the line, it winds up exactly on itself. For a parabola, it's always a vertical line that goes through the vertex. Because it's a line, we write it as an equation. Vertical lines are written x equals, in this case, x equals 4. The domain, once we have the graph, we can see our domain is all real numbers. There's no x values left out of my graph. And the range is all the y values smaller than or equal to 2. So starting down at -infinity and going up to 2, including 2. Sometimes it also may ask you for a maximum or minimum value. Notice this one has a maximum. The highest point is this one here. And that maximum value, it's the y value of that point, which is 2. The maximum y value, the highest y value is 2, which makes sense from our range. So that's graphing from vertex form. Let's take a look at one where we are given standard form. So if we are asked to graph a parabola from standard form, y equals ax squared plus bx plus c, you need to start by getting the vertex by doing -b divided by 2a. B is 6, so if I plug in 6 for b, and a is -3, we should be able to get the x value of the vertex, 1. And then we're going to set up an xy chart. 1 goes in the middle of the xy chart. We pick 2 points on each side of 1. 0 and -1, 2 and 3 would probably be good choices. And we are plugging all those values in for x into the original equation. So -1 squared is 1 times -3. 6 times -1 minus 2. Plug in 0. 0 plus 0 minus 2. Plug in 1. 3. I'm sorry, -3 plus 6 minus 2. Plug in 2. 4 times -3. 6 times 2 minus 2. These two matched up. That's a good clue that you're doing it correctly. This last one should be -11, but you should probably plug it in just to check. 9 times -3, 6 times 3, -9 minus 2. Yeah. We did not translate it all, so we don't need to worry about from our translated point. These are points on the actual graph. Those are the points I want. -1, -11, 0, -2, 1, 1, 2, -2, 3, -11. And again, I've got a pretty terrible looking parabola here. That looks a little better. So if we're in standard form, -b divided by 2a gives me the x value of the vertex. And then we're going to set up an xy chart, oops, an xy chart over here, by putting that in the middle, 2 points on each side. The last type of problem looks like this, where they give us the graph of a parabola, and then they ask us for the equation. If we know what the vertex is, we want to start with vertex form. We're thinking through the translation. This translation is left 1, 2, 3, 4, down 1. So I need my translation to be left 4, down 1. So to get left 4, for it to be left 4, this needs to be x plus 4. Down 1, so that has to be -1. If it's a parabola, and it is, based on the graph here, this has to be squared. And we don't know what a is. We know a is positive because the parabola opens up, but let's just leave it as a out there. We need to figure out what that a value is. It is not rise over run. This is not a straight line, so you cannot find the slope there. Instead, what you're going to do is take another point, not the vertex, but any other point. This one would work. This one might be easier. -2, -2, 5, and plug it in for x and y. And we should be able to solve for a. That's 2 squared. This is not 3a on this side, because this is 4 times a minus 1. This should be 4a minus 1. Add 1 to both sides and divide by 4. Final answer, y equals a, which is 3/2, times x plus 4 squared minus 1. And that is graphing parabolas, or writing equations of parabolas given their information.